assignment, which is the other one I want to look at today. Guys, task 2 is on the equation of the line, which I hope is something that you've seen before. This is something we do with a set of results. So in task 2, you have to plot a graph of these results. So that's the first part of the task. Putting voltage on the horizontal axis, the x-axis, and therefore power on the y-axis. So the first stage of this, and I'll be giving out some graph paper, is just to plot the graph. Then you've got to use this equation, this graph rather, to find the equation of the line. So let's talk about that for a minute. If I plot these results, power on the y-axis and voltage on the x-axis, power is on the y, voltage is on the x. So the general equation of the line uses y and x. So it states it as y and x. But when you do your equation of the line, you can substitute P for power for the y value and V for the x value. Okay. If I plot this graph, I might get a set of results that looks a bit like this. And experimentally, this is something that quite often happens. You do the experiment, you get the results, you plot the graph, and there's a rogue result. Something that you probably made a mistake somewhere along the experiment. So if you've been sensible about it and actually kept all the experiments together so that you can go back to it, you might want to go back and have another look at this particular result because it looks a bit dodgy. Other than that, all you could do is say, well, actually, all these other results lie on a straight line, so maybe this is just a mistake. It could be that actually something very interesting is happening at that point to this material or to this current, if that's what you're looking at. Okay? But it probably is that, in fact, there's some sort of error. So if you've just got one rogue result, you might be tempted to draw a straight line through the center of the results and ignoring this rogue result. And if you do that, you would state you're going to ignore it and why. So that's just a general point. I'm not saying you're going to get a rogue result in the task. This is just a general thing that often happens. So when we get a set of results like this, and we plot a graph and we get a straight line, that's what we're after, actually. We're after a straight line. And next year, we'll be looking at ways to get a set of results that do not fall on a straight line, but might be some sort of curve like that, which is a familiar shape, or a curve like this, or some sort of curve like this. Next year, we'll be looking at, maybe a bit this year as well, other shapes of curves, but whatever shape you get, you then try and manipulate the results to get a straight line. You play around with what you plot to get a straight line. So the bottom line is we want a linear relationship like this. So then we can find the equation of the line, because the equation of the line gives us a formula that relates, in this case, power and voltage. Often in engineering, you're using them already, you use formulae. And how are these formulae arrived at? Quite often from a set of results and plotting a graph to get the relationship between one variable and another. So this is not something that happens uncommonly in engineering. Some sort of experiment to find a relationship between two variables. So we're after the equation of the line now. How do we get the equation of the line? So let's just summarize the main points. I'm hoping it's something that's not going to be unfamiliar to you. You would have done it in the past, I'm sure. Here's my line. The equation of the line is this. Y equals mx plus c. That's the equation of a line. And it relates whatever you're plotting on the y-axis to whatever you're plotting on the x-axis, as I've said already. So it might not necessarily be y and x, it might be power and voltage, or force and extension if you're doing some sort of Hooke's law experiment. So y and x represent whatever is on the y and x axis. Could anybody tell me what m represents? Yes, it is. Well done. The gradient of the line. So we use the symbol m to represent the gradient. And we find the gradient by drawing a triangle at a convenient point. And this is often a convenient point. Because the gradient is the slope. So we're after the slope. We can draw the triangle wherever we like. We just take two convenient points and draw in a triangle. We could even go down here if we wanted to and draw one in like this. Any two convenient points, because the ratio of how far you go up to how far you go along is the same wherever you draw the triangle. They're all similar triangles. So you just pick two convenient points on the line and put in a triangle like this. And the gradient, m, is how far you go up divided by how far you go along, y divided by x. So this is y and this is x. Beware of this. Y is not this value here. Y is not this value taken from there. Y is the distance from there to there. So to get y, we have to do a little subtraction. We have to find out what this value is and subtract what this value is to get y. Okay? And if I hadn't chosen this convenient 0 point for x, I'd have to do the same for x. So y and x are the distances. Y is this distance from here to here. X is this distance from here to here, taken from the scale. And once you've got those values, you subtract y by x to get the gradient m. Anybody tell me what c represents? Sorry? It's a constant? Yeah, but we can get it from the graph. Can you tell? Where it cuts. Yeah, it's where it cuts the y-axis. Exactly right, yeah. Okay? If x was 0, then if you think about it, m, the gradient, times 0 would be 0. So y would turn out to be just c. So if I go to where x is 0, which is this point, then that will be the value of c. So c is the y-intercept. Y-intercept, where it cuts the y-axis. And that's here. So once I've plotted my graph, I can easily find the equation of the line. I can find out what m and c are from my results by plotting a straight line graph. And then I can use it. It's a formula. If we just take an example, so the equation of the line is a formula. Or gives a formula. Which is its use. Engineers like formulae. So if, for example, m was 3 and c was 5, for example, then I could write y equals mx, so 3x plus c, and c is 5. So if somebody told me what x was, and remember in the task x represents the voltage, somebody told me what x was, I could calculate y. If x was 4, what would y be? $17. If x was 4, 4 3s are 12, plus 5, 17. Okay, so given a value for x, I could find y. Slightly more awkwardly, given a value for y, I could find x. A bit more awkward because I'd have to rearrange the formula, but I could find x too if I was given y. Okay,